Okay. Section 3.1, we're going to go ahead and skip that because it should be something we already know. It's reference angles. I put it in when you were doing the 17 special angles and we had to find the different measures. But if you want to go back and review, it's section 3.1 and it's reference angles. They'll come up again, so it's not like you won't have a chance to review them. What we're going to do in section 3.2 is actually work with radian measures. And what you'll find out is what we've done so far is measure everything with degrees. So now we'll be able to figure out what is a radian measure, and then we'll be able to convert our degree measures to radians. So think of it as just two different ways to find the same measure, just the same way you would if you had inches and feet. Okay, it's going to review a little bit in your book about angles and their measures and degrees. We already know that if you have an initial side array and then it rotates a certain amount, it ends on the terminal side. And then we've been finding this angle, but everything we've found in this angle so far has been in degrees. Well, what you're going to be able to do now is tell me what is the radian measure of that once you learn how to convert them. Here is still a little bit of review about 0 to 360 degrees. Just showing you the fractional part of 360, how it equals 30 degrees. Probably an easy way to think of it is like this. You have 90 degrees, that's 1/4 of 360. Which will come back and probably help you when you learn how to convert to radians, thinking about the fractions. Alright, what is a radian? I always like this diagram because I think it shows it pretty well. It says 1 radian is the angle of an arc created by wrapping the radius. So you're going to wrap the radius of the circle around its circumference. In this diagram, the radius has been wrapped around the circumference to create an angle of 1 radian. The pink line shows the radius being moved from the inside of the circle to the outside. So if you notice, they're showing you the angle of 1 radian. They're taking this radius and they're actually curving it so that it represents that part of your circle, which we've been used to seeing that as an arc, probably in geometry, which is going to come to play in the next slide. A second way to measure angles is in radians. And that's what we just talked about on the last page. What was the general definition? But how do you apply it in a circle? Well, 1 radian is the measure of a central angle, theta, that intercepts the arc, S, equal in the length of the radius. So again, it's showing you have this radius. And you notice what they're showing you here on your circle. They're saying right here that S equals R. So whatever this was, they're showing those two things as they wrap around that circle. So if you have to find this degree measure there, all you're going to do is say theta equals S, which is the length of the arc, over the measure of your radius. So when you see it where it says theta equals S over R, they're talking about this definition. So if you know the length of the arc of the radius, you can find the angle, and then you'll have some problems where you'll go vice versa. They may give you the angle and actually go back and find either the radius or the length of the arc. Alright, so here's an example. You have a central angle B, so you have some type of circle, and you have a central angle beta, we'll call it beta, in circle of a radius of 3 centimeters. So if you have a radius of 3 centimeters, it cuts off an arc of a length 6 centimeters. So the radius is cutting off an arc of 6 centimeters. So they're telling you this is 6 centimeters. What is the radian measure of B, or beta, whichever way you want to say it? So we're going to go back to what we just learned. Theta equals length of arc over radius. So we're actually trying to find out what beta is. Then we'd say the length of the arc, which was 6 centimeters, divided by the radius, which was 3 centimeters. So beta equaled 2. So remember, anything in red is your responsibility, so there's a practice problem. Alright, what you need to make sure that we pick up on is that pi is the same thing as 180 degrees. Well, when we're talking about pi, we're talking about a radian. That's going to be your conversion factor. It's going to be pretty important because that's how you change radians to degrees. So when you're talking about conversion for radians to degrees, you'll see what it means right over here. This one's obviously the key because that's the conversion factor. So pi radians corresponds to 180 degrees, 1/2 of your complete circle. 2 pi radians, the same thing as a complete revolution. Pi over 2 equals 90 degrees. If we're talking about a general measure, that's when you go back and use your pi as being 3.14. And when you talk about converting radians to degrees, we're going to use pi as being equal to 180 degrees, which you'll find out in this slide. So you should be able to convert from degrees to radians and radians to degrees. If you want to go from degrees to radians, you multiply by pi over 180. If we want to convert from radians to degrees, you multiply by 180 over pi. So here's your first problem. You have 40 degrees. They want us to convert it to radians. So we go degrees to radians, we multiply by pi over 180. So you'll end up having 40 pi over 180. Well, you have to take that and put it in those terms. So the 10 is going to factor out. Then go ahead and divide both of these by 2. So that gives me 2 pi over 9. So 40 degrees is the same thing as 2 pi over 9. So you've taken degrees and converted to radians. Now let's take radians, which I gave you as pi over 5, and multiply it by 180 degrees over pi, because you're converting radians to degrees. So remember, you multiply by pi over 180. And what you'll notice is in your conversion factor, these should knock out. So now you have 180 degrees divided by 5. Well, 5 is going to go into 18 3 times. So that's 15. That means there's 30 left over. So 5 goes into 36 times. So 36 degrees. So you converted pi over 5 to 36 degrees. So that's what they're looking for. Here they were looking for 2 pi over 9. See if you could write it in radians. What I'd like for you to do on this part, just to practice, identify the following radian measures as degrees. So you should be able to take each one of these and convert them into degrees. You have to go back and make sure you remember, what do you do when you convert radians to degrees? Do you multiply by 180 over pi, or do you multiply by pi over 180? Alright, there's our 17 special angles on the unit circle. What I've asked you to do is identify the following special angles in radian. It should say in radian measures. In radians. Let's just put in radians. Then identify the xy coordinate of each angle. Please write your answers right on the unit circle above. So your job is to convert each of these degrees, convert them to radians, and when you convert them, just write them right outside the angle that you're working with. Make sure you include 0. Then what I want you to do is identify what is the xy coordinate for each angle. So you have to go back and think about xy coordinate. How do you find the xy coordinate for your 17 special angles? I will give you a hint. It has something to do with your trig functions, sine and cosine. But I'm not going to tell you what it is. You got to go figure it out. Which is good because it's going to make you practice going back and reviewing with your exams coming up, so it's not going to hurt anything. So go back and identify what are the xy coordinates for each angle that's listed up here. And then you have to also take each one of those degree measures and write it out to the side here, whatever your radians are, and then identify your xy coordinate. So when I look at your piece of paper, each one of these should have that information all the way around there, right on your circle. Alright, you're going to have some problems where they ask you to evaluate certain equations or expressions. So you have 4 times the sine of 2x plus pi, but they're telling you x is pi over 6. So I have 4 times the sine of 2x, but they're telling me x is pi over 6 plus pi. So you always do what you would do with any type of problems. Clear the parentheses first. So 2 divided by 6 is going to leave me with 3. So in my parentheses, I have pi over 3 plus pi. Bring this down. Well, now you have to go and simplify pi over 3 plus pi. Well, remember what we said? You could go pi times 3 is 3 pi plus pi gives you 4 pi over 3. So where our parentheses was, we could simplify that to 4 pi over 3. So now you have to go and find the sine of 4 pi over 3. Well, go ahead and convert 4 pi over 3 to degrees. Remember how you do that? You multiply by 180 over pi. That's pi right there. Sorry. So remember, those are going to knock out. 3 goes in 180 60 times. So 4 times 60 is 240 degrees. So what you really have to find is 4 times the sine of 240 degrees. Well, do you remember how to go find this? It has to do with reference angles. So go ahead and draw your xy. Remember, that's 180. That's gonna, if we go down, that's going to be another 60. So you know this measure is going to be 60. If that's 60, you should know that's the square root of 3. This is going to be 1 and this should be 2, but remember your signs over here. So if I ask you to find the sine of 240, well, you're going to go opposite over hypotenuse, which is going to give you negative square root of 3 over 2. Remember, you're going to go back and multiply it by this 4, so that's where that came from. 2 goes into 4 twice, so your answer is negative 2 over the square root of 3. Okay, that's your last slide. So see how you do.